We're in recording mode. So I'll just give it a couple more minutes and I'll start because we've got quite a lot of material to cover, which I want to cover. And Ahmed, I mean, have you done any programming up to now? Have you done some programming before, or yeah? All right, okay. So okay. So what do you want to do? Are you aiming at university at the end of this year? I mean, do you want to go? Yeah. What do you want to do there? Good. Okay. Okay. And what do you think are the most important uh, areas for an engineer to be competent in? I mean, is it just physics and maths, or do you need some computing, or what do you think? Yeah. Yeah. Well, what sort of engineering do you want to do? Electronic. Good. Yeah. I spent many years teaching in a department which specialized in electronic engineering, so and microelectronic engineering too. So I'm not an engineer in that sense. I'm not an electrical engineer, but I see myself as being a digital systems engineer because I can create systems and on chips, and I've always found that quite interesting. Okay, the others are late, so I'll make a start. Give you an overview. It's May the 7th today, obviously, I think, most parts of the world. And just to review a little bit of what we did last week, I mean, we considered of quite importance, what was quite important was fragmentation in IP, in the Internet Protocol. Sometimes there's a need for fragmentation of large packets simply because a router might not be able to cope with or might not wish to cope with very large IP packets. So at the end of the session last week, I discussed how you can very easily adopt an algorithm for breaking up an IP packet into lots of subcomponents. And the key thing is that each packet will contain an offset number. And an offset really represents a group of something like 8 bytes. So an offset, an IP packet, when it's been fragmented, one of the fragments might contain offset 600. And what that really means is that the first byte that it contains is the 800th time eighth byte in the original uh, sequence of bytes that one was going to be transmitted. And we discussed them. And for some people, that's quite boring. Some people uh, uh, think that the structure of an internet protocol is quite boring. But there's a certain logic to what you do find in each of the internet uh, types of protocol. I mean, there's TCP and UDP and IP and so on. And one of the things good morning, Radhat. Good to see you. One of the key things is when it comes to discussing and comes to understanding uh, packets of information is how they fit into what's called the protocol hierarchy. And if you remember, I showed a diagram with lots of different layers. Um, and at the uppermost layer is an application which actually needs the services of the next lower level, and the next lower level probably needs the services of the layer below that until you get to hardware. And then at the hardware level, that's actually going to manage the transmission of packets themselves that have been passed down the protocol. So I want you to, just think a little bit about that again. And I'm just reminding you of what some of the things that we did last week. And we looked at a technical definition of a stream. And the reason for that is that streams are a very, very important part of communication in Java. And what my intention today is simply to uh, give you an overview of what's involved in internet communication and we'll be using streams and TCP as well. So streams, and hopefully you can remember what a stream is. And I sort of offered you a fairly easy way of coming to understand a stream as being a doorway onto a real communication channel, and it might be a hardware channel. So just bear that in mind. And a stream comes in two kinds. One is an output stream, one is an input stream. And streams are essentially unidirectional in the sense that I can only send data in one direction. I can't also receive data through that gateway. I can use the gateway to send data. And as far as input streams are concerned, I can use an input stream to input data from the communication channel. So, I mean, the analogy, I suppose, is you've got a microphone and you've got a loudspeaker 100 meters away, and I can use the the actual communication channel, namely the wire that connects the microphone and probably a little bit of a few electronics to the loudspeaker. I mean, the microphone is going to allow me to enter data onto the communication channel, namely my voice. And the loudspeaker is very much, it's analogous to an output stream in the sense that it allows an audience to hear the data that's being transmitted over the wire. So, but there are lots of different variants of streams and lots of different communication channels that you can think about. And in the limiting case, you can think of I mean, this takes a little bit of imagination, but you can imagine a file of data or file of text stored on a hard disk as being a communication channel. And the reason being is that I can have an output stream connected to the file in such a way that I can read the file, I can get the text out of the file. And similarly, I can think of an, an output stream connected to um, the file in the sense that I can create data to put into that file. And the other example, extreme example, was um, uh, using a screen as sorry, as an output stream in the sense that you can think of a screen as a gateway out of which comes visual data. So anyway, that's sort of giving you a fairly long-winded partial summary of what we did last week. But I want you to bear in mind the questions. First of all, why is there a need for fragmentation? Why do you need it? Why have we bothered to think about fragmentation? And I want you to have a very clear idea of how an IP packet can be reconstructed at the receiver. And moving on to streams, I want you to focus on and read up a little bit about streams. I mean, it could be, the material I've given you, or it could be material from one of the three ebooks I've made available to you. I mean, look at streams. I mean, try and be able to give me a very clear and uh, rigorous definition. I've given you a fairly informal definition of what a stream is. So the take-home message from last week, because I'm quite fond of just repeating myself to reinforce your understanding and knowledge. They're unidirectional, they're unbuffered, they are randomly accessible gateways into or out of any real communication channel. And very, very importantly, from a programming point of view, because streams are actually a software component, uh, streams provide a uniform way of dealing with communications over any channel, whether they be microwave or UDP protocol or TCP networks or files or screens. I'm not sure what I mean by screens, and who knows what else. I mean, you name it, and in principle, Java could offer you a software component that allows you to write data onto that channel and to read data back from that channel. So it makes the programmer's life very, very, very easy. And all I mean by the latter is that a stream offers a method. I don't know why I've got, I mean, that's a bit messy. I've got, let me just try and just delete that. Offers a, let's just stay with a method. Um, in fact, it's a void method. I mean, it's like a function, but it's something that doesn't return a value. I mean, a function like the square root of 9 returns an integer value. A write operation, however, performs an operation, performs a specific operation, but it doesn't return a value. And a stream is going to offer you methods to send and receive bytes and integers and strings and lines of text and even, believe it or not, objects themselves. I mean, it's entirely possible to actually send um, an object from here to Timbuktu. And what the object might represent is a working program. And what I can do is to send an object to a remote host and start it running. And what it might do is it might be, it might take over that machine. I mean, it's quite interesting, the possibilities of being able to send objects, because in Java, objects, if you remember my definition, is simply a packaging of some data and the operations that execute work on that data. Anyway, and here's a little bit more to think about. One might think of an abstract class or an abstract interface called break. Let me explain. I mean, motor cars and e-cycles and sledges and rockets and moon landers and skating boards and aeroplanes all have in principle an operation of slowing down their speed or velocity. And a brake operation in maybe what's a subclass of brake or a subclass of brake called brake space vehicle or another subclass of brake e-bike will be implemented. The break operation found in the subclasses of break, which offers maybe an abstract operation called break with a capital B. You'll end up implementing all those uh, operations in each subclass quite uh, separately and quite specifically for the kind of vehicle that you're thinking about a brake. I mean, an e-bicycle has a brake, and this will be implemented specifically for an e-bike. I mean, a braking system on a space shuttle involves, I don't know, 12 retro rockets to stabilize motion whilst it's reducing its velocity. And the idea here is simply to write a byte on an ultraviolet transmitter is going to be quite different from sending a byte using microwave communications or transmitting a byte on a, I don't know, it should be an 8-bit bus here, an 8-bit, an 8-bit bus, or by sending a byte by human courier. I mean, they all involve uh, some generic write operation. Well, my long-winded effort to make the point is that Java is going to give you write and read methods that will apply to any conceivable communication channel that you have um, in the Java language. I mean, you have to, somebody has to do a lot of extra work, but these generic operations are going to be available to you, and it makes life very easy for the programmer. I mean, I don't have to write 300 lines of assembly in order to implement a write operation to be used on a microwave transmitter. So, so okay. So one other things from the streams part of last week's discussion was that we can actually compose different sorts of streams, and the purpose of doing that is to derive a, a different and perhaps a more appropriate set of methods for reading and writing a communication channel. So, for example, I can read or write single bytes, or maybe by composing one stream with another, I can write bigger chunks of bytes, such as an array of characters or an array of, I don't know, integers or whatever. And we mentioned very briefly readers and writers. And you can think of readers and writers as being um, very much like an input stream or an output stream. And uh, you can what you'll do is to find methods that reads lines of data. In the case of an input stream or a reader, I mean, in the case of a reader that's been combined with an input stream, enables you to read whole lines of text, for example, a bigger, more appropriate uh, uh, kind of data or data type uh, fit for fit for your programming purposes. Or a data output stream can be used to write to an output stream, such things as long integers or arrays of bytes and so on. So the idea of composing one stream with another, or one reader with a stream, or one uh, other stream-like object with a stream, is to alter what you can actually do uh, with the stream, like in terms of what you can say, perhaps you can actually read a much bigger chunk of data, or in other very sophisticated cases, you can read objects from uh, what uh, ultimately is nothing more than a stream. So what I want to just give you a little example about is a data input stream is built using composition with an input stream. So in other words, the way in which you compose a data input stream object with an input stream is to write a new data input stream, which is the class data input stream, with the name of an input stream. So a practical example might be Clever Clogs has a type data input stream because that's the object that we're about to create. And it results from creating a new object from the class data input stream, which is attached to system.in. Now, you probably don't know this already, but you might have come across it. System.in is a very basic input stream. Its name is system.in. So that looks uh, like a bit of a nightmare, but just sort of interpret it in the way in which I've interpreted that. Clever Clogs is the name of a new data input stream object, which is composed with a stream. And I'll, show you a diagram for that, a familiar diagram for what's happening here. In general, creating a new object uses a class's constructor. And a constructor's purpose is to simply attach a stream or take some parameter or other in the general case of object creation. And the new keyword, the keyword new, composes the two objects. I mean, that sounds horrendous, but it's not really. So what I'm doing is in Java is to create a composite object. And what I have in mind is, okay, I think this is, let me see, I think this is going to be um, a data input string. So the red object represents, sorry, the red object represents an output stream, such as system.in. So a very simple output stream, which we learned about last week. And the blue object is a data output stream. And I'm composing the two. Okay, I'm creating this simply by saying, wait a minute, simply by saying, where am I going? I should be going backwards, wouldn't it? But I'm going, this is actually giving me, oh dear. All right. Uh, okay, so I've created that object I've just shown you by writing clever clogs as a new object formed by attaching an input stream to this subclass data input stream, and so I get that. So I'm just going to, if you don't mind, I'm just going to take 5 minutes off. So I'll see you very soon. So apologies, uh, Ahmed and Raquel. We just had a slight emergency in the back of the house, so that's all sorted out. And hopefully I wasn't much longer than 5 minutes, so we'll continue. Okay, so the point of creating this new composite object is simply to enable us to be able to access more appropriate methods. All right. For example, the blue object will actually offer us methods W1 and W2 here, which it's wrong. I mean, it's what we do need, and it depends whether we're thinking about an output stream or an input stream. If we create an input stream from the basic input stream and maybe what's called a buffered input stream, is that we're going to get three methods which are highly desirable. If we're thinking about this as an output stream, then this will give us these methods, which are absolutely what we do need. And this will be the red object here, in that case, would be a very simple output stream. So a question is, supposing we write CK is the composite of blue, red with blue, then to execute methods W1 and W2, all we need to do is to write CK dot W1. So this is CK, and that's going to offer us methods W1, W2, and W3. If I wanted to execute method W1, we have to prefix it with the new object name. I mean, that might sound a bit scary, but what I'm intending to show you shortly is some program code that will read bytes from a stream and will then write it out on another stream. And a way of doing this is to first of all use the following line. So n is going to be the result of reading an array of bytes using this stream, and I'm assuming that n is assigned the number of bytes resulting from executing read buff. In other words, I'm doing the read operation by using the read method found in fin. This is the new object I will have created, and I'm going to assign to n the number of bytes that I've actually just read into buff, this array of bytes. So buff is an array of bytes, and simply this reads the data and returns the number of bytes read. And as I said, the read method will belong to the object fin. So I'm going to show you in a moment this example. Okay, we can attempt to repeatedly read an array of bytes from a stream like object, such as a buffered reader. And the read operation will return a -1 when there are no more bytes to be read. So here I've got the same operation. I'm attempting to read an array of bytes into an array called buff, and the read method is available in the object n. And what this read operation does is to return the number of bytes read into n, and I'm assigning that to n. And while n in effect is greater than -1, I can write the bytes out onto another output stream. I mean, I'm making things sound terribly complicated, but this is the key part of data transmission from originating from one stream to another. And in case you hadn't cottoned on, fin is actually going to be like a file input stream. A file input stream. I'm going to create a file input stream in a moment. File input stream, and from that stream I'm going to do a read, and whilst the number of bytes I'm reading is greater than -1, I'm going to send it out on a different output stream. And the convention is that uh, what what n equals -1 indicates is that there's no more data coming. You finish. That's it, and you can just exit from the program. So I want you to examine the cffile.java program I'm going to give you very carefully and try running it on Eclipse. Now, what I'm going to try and do now is to share my screen, and I'm going straight into, hopefully, so I'm sharing my screen, and this is my Eclipse, and this is my file called CF, short for copy file, and I'm putting into practice everything we've learnt about streams. So listen very carefully. Ignore this commented line. And in Java, if you get two parallel lines like this, it just means that what follows is comment. Because I've just commented this particular line that you could have used out. And my first line is fin is going to be of type file input stream, and it results from creating a new object from the subclass file input stream. Remember, file input stream is a subclass of the mother of all input streams called input stream. So I'm creating a new object from this subclass, but I'm attaching it to the name of a specific file. Here's the name of the file. And all I have to do is to give it path name. So it's C blah, 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 blah. And the actual file is called Gutenberg.txt. And what I'm going to do is to, what this line does is to open the input file, in effect. It opens the file. And it's this file that I want to be copied. And in contrast, I'm going to create a file output stream called fout, and that results from creating a new instance, a new object. Sorry, I'm going to create an object from the subclass file output stream, and you'll remember that file output stream is a subclass of output stream. So I'm creating a new instance of it, but I'm attaching it to this file. I'm linking it to this file. Remember, this file is also can be regarded as an input stream. A file is, or an output stream. In this case, it's going to be an output stream. This case, look, in this case, it's an input stream. I can think of a file as a communication channel from which I can I can use it as an input stream, and that gives me very simple operations like get a single character, or get a single character, or get a single number from this file. But to do that, I need to connect the actual communication channel to this stream file output stream. So you're going to have to think maybe quite a lot about this, but it's quite short. Let me just read it again. Fin is of type file output stream. Well, it's a name. This fin is a name. What's it a name of? It's the name of a new object created from the subclass file output stream when that's attached to a particular file, a particular communication channel, a particular if you like, input stream. You can think of that as an input stream. Okay. And that's quite consistent with what I showed you a few minutes ago when I was reviewing what we did last week. File output stream is a FL is a file output stream, and it's created from this subclass of output stream, and I'm attaching it to the name of this particular file, and it's going to be an empty file. It's an empty file, and I'm going to talk about arrays a bit later on and the way in which you can create arrays. But buff is just an array of 16 bytes, and it hasn't been initialized to any data. It, n is simply an integer variable, and here I've got this while loop. So have a look at this. While the data I read using fin, so I'm using a method called read found in input stream. Whilst it's not equal to -1, I'm going to write the same data out. It's an array of data, buff, starting at the index 0 for n up to index and including index n. So I'm just sending out the buffer from, it's like buff 0 all the way to buff n -1, in fact, out onto this channel F out. And finally, all I have to do is to um, tell the user that the job's been finished. Well, no, I can sort of run that. That's file, and I'll get the done message at some point. Hopefully, is it coming? Yes, I've got it done. So, believe it or not, what's happened in the background is that a very large file called Gutenberg.txt has been copied into the rather curiously named file topid.txt. I think that should be copied.txt. And that's located in um, archive 2. And I mean, I think I'll risk upsetting the system if I show you the file, but it will contain the entire contents of Gutenberg.txt. And so just to repeat the logic of this, I'm creating a stream, attaching it to a communication channel, which is a bit of a, might sound a bit odd, but a file is a communication channel. It's the name of the file, Gutenberg.txt. Creating a new name into which I want that file to be copied. And how do I do that? Well, first of all, I create a file output stream because I need a file output stream to give me the methods I need to write data to a file. I need that. And the way in which I do it is to repeatedly read an array of data from the file until there's no more. And every time I do a read, in other words, n is, I mean, maybe 12 bytes or whatever, um, I'm going to send that array of 12 bytes out to the new file. So I'm going to do a write operation on the file output stream f out. So I'm going to, I mean, I'll give you this program, but what I want you to do as homework, yet again, because I give you weekly homework, whether or not you do it, it's very much up to you, but I advise you to do it, is to, using Eclipse, just copy and paste the program I give you and run it and set your own parameters. I'll probably give you the Gutenberg file as well, because I think this is about the third time I've told you. It's a very interesting historical document about the Norman invasion of England and how English people became slaves for 100 years or so from the French, William the Conqueror. So I'll give you the file, I'll give you the program, and all that you need to do is to make sure that you uh, installed Eclipse, and you can paste the program into Eclipse and run it using run, right? And this is one way, and a bit later on, I'll probably show you how to use this. In case I haven't already shown you, I can use run configurations, and I can specify the arguments I want to put in. I could give the full name of a file here, space, full name of a file here, and then just run the program. But I'll show you how to do that. And what I need to input into run.configurations are are the actual string names of the file. So, and then I could use this line um, to get, and I could replace the name of this file by args.0 because it's the first array of strings that I've actually specified in the run configurations file. So I'm sorry if that sounds a bit difficult, but don't worry, don't worry about too much about that. Okay, so I'm going to move on. Raghad, Ahmed, I don't know whether you've got any technical questions at this time, or you need a bit of time to, in your own time, to actually decipher what I've been telling you. I mean, it might sound a bit tricky, but it follows on from the work that we did on streams last week. Okay. So, Raghad, are you still with me? Have you gone home? Have you left me? Hopefully not. So, I'm going to move on a little bit. So, I'm going to upload another presentation, and I don't see any reason for not going the whole hog, as we would say, by looking at uh, socket clusters. So one of the things I intend to do today is to look at TCP a little bit, but I'm going to talk about the socket class. And and it's not January, I realise that, but it's quite a recent document I wrote. So I'll just see if I can just cross it out. So just to mess things up a little bit. So it's not January, it's February. So I'm going to introduce you to the idea of a socket in communications, network communications. And the background is that we're going to use a protocol called TCP. And I'm going to talk to you today about TCP. And I had to sort of decide whether or not to talk about TCP before talking about sockets, or whether I could talk about sockets because we know a little bit about streams. So I decided on the latter. So I'm going to talk about internet programming using sockets. So hopefully you're reasonably comfortable about that. Okay. So so supposing it's required for us to communicate between A and B, where A and B is separated by the entire internet. I mean, it's opposite ends of the internet, if we can talk like that. So we need to allow A to communicate with B uh, via the internet. And it's a very, very general problem because as you already know, I think, the internet extends into space to many, 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 many millions of miles away. So I want A to be able to communicate with B over the internet, wherever that takes you, wherever you are. I'm going to show you how to do that in practical terms. So let me just let me see if I can do that. So I can't quite move the slide onwards. So just try something else. All these problems I face. No. Okay. I don't. Okay. So what is a socket? You can think of a socket for the time being as an object that has an address and something called a port number. And a socket will be typically used by an application on a host. All right. So think of a socket as being an object in Java terms. So remember, it has some data and it contains a number of methods, or if you would prefer, operations. And it's going to be used essentially for communication purposes. And an IP address is a 32 bits number, and every machine on the internet has an IP, what's called an IP4 address. It's 4 bytes, so it's 4 times 8 bits, 32-bit address, and a port number. And a port number you can think of simply being the name of a particular process. It's like an index for a particular process running on a particular machine. And uh, when I talk about an application, I'm talking about something like Zoom. And if Zoom's communicating with you, it's going to communicate with you not necessarily by TCP, but it'll communicate with you at your IP address and a particular port number. I mean, it could be port 999. Well, it's not actually. I mean, they have well-known, what are called well-known ports. But a port number just signifies is linked or associated with a particular application running either on the sender machine or the receiver machine. And let me just try and move on again. I've got the same problem. Okay, so these little rectangles simply represent the socket objects, and I'm using these to communicate. So why oh why am I having problems? Let me try the down page. Okay, that works. So in order for a machine to connect to a remote host, you need to specify the port to connect to, and you need to specify the IP number. And if there's no server listening on the remote port, the connection fails. And technically speaking, something called an exception, sorry, I've got a line there. An exception is going to be thrown in order to create the socket. So let me just say that again. If I wanted to connect to your laptop, then I create a socket that specifies your IP address and a particular port number that I think you are monitoring, or you have a server monitoring that port. And if a port isn't being monitored by a server, the connection attempt is going to fail. So a socket, in effect, represents uh, the endpoints of an input and an output stream. So that's important. So a socket, an individual socket, is an endpoint of either an input or an output stream. So what I have in mind is I'm going to create a socket. So I'm going to write something like new socket. I'm going to specify the host name and the host port, the remote host port. Alternatively, I can actually specify a 32-bit address and specify the port. So here's an example of how you begin to set up communications between one machine and another. You have something called sock, and that's a socket. It's a socket object, which results from creating a new object from the socket class by specifying the remote machine's IP address and a port number. So in a single line, a lot of work is going to be done for you. It's going to in effect, the set up the framework for internet communications between you and the remote uh, system. All right. Um, so the methods that come with socket, because remember, socket, you can think of socket as either a class or an object that you've created from the class socket. The methods are those that identify the remote host. Um, Let me try and get rid of this icon. So at the moment, let me make the screen large. The local and remote port numbers, as well as the extraction of streams to allow outgoing and incoming communications. And you will remember that a stream is unidirectional, so that if I want to send data to you and to receive data from you, I need two streams. An input stream to get data in from you that you sent me, and an output stream that will allow me to send data to you. So a socket provides methods for identifying two streams that are now associated with the socket if the connection has succeeded. So the method is, first of all, there's a method. So this is a method in socket, a socket object or the socket class, get input stream. And it returns an object of type input stream. So an example use of that is, first of all, you say, give it a name, ins, so it's short for input stream, so type input stream, and it's obtained from writing the name of the socket. So it's that's supposing it's called asoc dot, then the name of the method that will result in returning an input stream. It's get input stream. All right. So an example use of all that is that if you want to identify a stream on which you can communicate after you've created a socket, you just write that, something like that. Name of the input stream, so type input stream, and it results from using asoc's method called getInputStream. And exactly the similar thing holds for output streams. So there's a method in a socket, in each socket, called getOutputStream, and very similar, returns an output stream allowing us to write data to the remote host. So exactly the same. And for reason of efficiency, I'm saying something like a socket stream should be buffered. So the reason for that, well, how do you do that? I mean, you just have to take this on trust at the moment. I can first of all extract using get output stream, an output stream, but then I can compose that with a stream that buffers it. And by doing that, I'll be able to send big chunks of data. Rather than having to write data one little tiny chunk at a time, I'd rather transmit or transfer data one big chunk at a time. That's what I'm talking about, a stream being buffered. And when you've finished with the two streams, when you've finished with the socket, when you finish communicating with your remote partner, just close the streams down, or close the socket rather, close the socket. So it's just for uh, uh, efficiency in the use of resources, right? And if I want to, well, I've got lots of other methods. Like I can actually find out uh, what your remote port is. I can I can identify the local ports which I'm sending data on, and so on. So there's loads of ways of converting uh, symbolic addresses into 32-bit numbers. There's ways of utilities to return the information about the port that you're communicating with me on, and so on. So little bit of research. Okay. Um, whilst we could communicate via sockets alone, it's actually very useful to use a new class that I want to introduce you to called server socket, and and that will enable the socket to make a connection to a remote port on which a particular server socket is listening. And if that sounds a bit of a mystery to you, all I mean is that if you start using a server socket, it's going to be determined on which port the server socket is listening. In other words, it's waiting for a connection from you, right? The client, as it were. So a socket makes a connection to a remote port on which a server socket is listening. And before I can talk to you, which has this server socket up and running, I need to be told somehow or other on which port you're looking at, what port you're actually monitoring before I can connect to you. The server socket's job is to create a new socket for the connection on which all further communications can take place. And the situation is that whilst I'm communicating with you, another person or another client might come along and request a connection at the same internet address, in other words, IP address and port number. And if, however, the server which was listening on this port, like, so here are you, you're client number one, here's the internet, and um, you've actually got a connection on this port. What what the server socket will do is to create a brand new socket just for you, on which you, client number one, can communicate. So you've got a dedicated socket. in other words, you've got a dedicated pair of streams, an input stream and an output stream, with, um, by means of which you can actually communicate with the host, the remote host, using a particular socket. In other words, the socket's going to have a port number. It's going to have the same IP number, but a different port number. This socket. I mean, this server socket might involve port 80, but when you connect to that port, what the remote host is going to do is to create another socket just for you, just for this client number one, or client number two, or client number three, or client number 100. And what the socket is going to do is to provide a new port number, same IP address on which you can communicate to your heart's content. So the server socket creates a socket for each client connection by accepting a request for the request that you've in effect made to connect to the server. And the server can then extract an input and an output stream from each of those sockets and start communicating with the client. It's all quite neat. Let me show you in practical terms what all this involves. So you can create a server socket object by, first of all, giving it a name. Let's call it server or Chris's server. It's of type server socket, and I want to create it by forcing it to monitor port 99. So after I've executed this very simple line, look at it, server socket. Server is of type server socket, and I'm actually giving the name server to the object created using the server socket class by attaching the number 99. 99 is the port number. And what I'm actually doing is to actually use server socket's constructor function to enable the running server to monitor port 99. So this line of program code creates a server socket listing on the port, capital P, whatever it is. Okay, so ports you specify. It's up to you to specify. It could be 11,000. All right, and the server is actually going to monitor that particular port. And one very important key method that server socket contains is the accept method. Accept, because what accept does is, first of all, to accept your request for a connection, and it's going to return a socket, gives you a socket. All right? So it waits until a client makes or attempts to make a connection on the server port on which the server socket is listening. And how do you do that? Well, okay, you've got the name of a socket, new client, and this is the socket, so it's of type socket, that results from your server accepting a request. And if nobody puts in a request, uh, puts in a request for a connection, then this line will never be executed. This line will be executed only when a connection attempt is made from a client, and this will succeed, and it will return a socket, a dedicated socket for the client. And the socket is going to be new client. And since new client is a socket, what will be done is that you've identified the two streams, the input stream and output stream, relevant to this particular socket, on which you can then start communicating with the, your newfound client. So look, I've spent, I don't know, about not more than about 20 minutes just talking to you about sockets and server sockets. But in that time, we've actually learned, believe it or not, how to establish internet communications using the protocol TCP. So the steps are very straightforward. First, you create a server socket on a remote host, listening to a particular port. Then you create a socket on the client side, and you connect. There's a way of using, um, the act of creating a socket on the client side, a way of specifying the remote port that you want to connect to. And on the server side, the server socket performs an accept method call. And those are the three. Sorry, let's go back. Those are the steps needed. And remember, accept, it just returns a socket from which the server can access the input and an output stream attached to the client. And at that point onwards, the server can then receive or reply to commands sent to it by the client. I mean, what might a client do with a server? I mean, logically, it could actually um, send a request asking for banking advice, like what stocks and share values are, or what is the weather over Minneapolis, or what's happening in London. Give me a news blast from London. Okay, I mean, it's that sort of communication we're actually talking about at the moment. But on the other hand, it could be what the client might do is to say, well, look, I want a copy of this. I can't remember this very up and coming American singer. Uh, can I have a clip of her music? And the server can actually send using the TCP protocol the entire clip. So we're sitting on some quite important technology here in the sense that we're talking about what in effect is a universal method of communication. It gives us communication, and it can, I could get my my refrigerator talking to me via my phone. And I think I might have mentioned at some point earlier this term is that my uh, boiler in London can actually be controlled by my iPhone. And I've got the iPhone. I'm 300 miles away from home at the moment, but I can check on the temperature. And maybe I don't actually need TCP, but I don't know. I mean, I haven't bothered to investigate how communications take place, but I can send data to my boiler. I can talk to my boiler. I mean, it's pretty boring, but I can check to make sure it's not overheating or it's not doing something stupid. So, so I'll I'm st that's it. That's all I've got on uh, that's all I've got um, on by way of an introduction uh, to the use of streams using TCP. All right, so I'm talking about Java, and I'm talking about the Java programming language using TCP, uh, and as a consequence, using streams in order to use TCP. You see what I mean? So, are there any questions or comments about that? I mean, is this incredibly complicated, or do you think you can get your heads around this? Raghead, are you blown to bits by this development? I mean, everything's uh, coming together. I mean, we've looked at streams and um, and I just want to show you how they're used. My favorite way is to actually come to use streams by using TCP. But for me to give you a full understanding of what's going on, we need to discuss TCP. We've looked at IP and we know what a protocol is. We know what a protocol looks like, how it behaves. And I think I described a protocol as just being a special rule to enable communication to take place. And a rule is implicit in the actual physical structure of a protocol. And you remember that IP consists of an IP packet consists of a header plus data, and it's the way that is structured and the information that's given in the header that implies a particular rule for transmission. Uh, I mean, the receiver can actually look at the incoming bits of the packet as it's transmitted and actually recognize, well, at least part of the remote system can actually recognize that what this is an IP packet and it has to be dealt appropriately. And any data it contains uh, may be handled in a particular way. I mean, the IP packet, when it's received, might contain a TCP packet. So what IP will do is to send the TCP packet to the TCP software, and the TCP software will actually know uh, exactly which port the TCP packet was sent to, and send it to the appropriate application that's waiting for data, and so on. Any comments? So let me just pause there for a while. Ahmed, I'm sorry. I mean that must be pretty hard for you, but I'm giving you the bare bones of something that is certainly at A-level standard, I think. So hopefully we can absorb some of the principles, some of the ideas, think about some of the ideas as part of the process of being able to perhaps program in Java using TCP. And I guess the thing I want you to notice, so I'm afraid I'm gonna pause the main recording because if I go much over an hour, I lose the entire recording. But I've got a separate recording taking place at home. Um, what I'm really saying is that the program I've demonstrated to you, which use streams to copy a file, is not profoundly different, isn't too different from being able to communicate data over the internet. And if you think about it for a moment, so listen carefully to what I'm about to say. The file copying program uses two streams, an input stream and an output stream, to read the file line by line and to copy the file line by line into a new file which is supposed to contain a copy. So that's the logic of the overall logic of the situation of a method of copying a file. You use a stream to read it and a stream to write it. Well, let me, uh, I mean, I'm sure I've mentioned this before, but think of a situation, a new situation where you want to send a file to the Mars lander. Maybe it's actually a file actually contains an extensive a program for reprogramming the Mars lander, and I want to send it from base station uh, in Florida all the way to to Mars. Well, what do I have to do? I have to first of all read the file, read the program line by line using a stream and sending it out over the internet on an output stream line by line. And okay, I've got a TCP connection with the Mars rover, and I'm going to send the program using TCP. I can do that, and it's so easy. Logically, it's so easy. What do I have to do? I open a file, read it line by line, repeatedly, until there's no more to read, and then I've finished. Because at each step, I've actually sent the line I've just read from the file, read from the program that contains the file. So I read a line from the file that contains the program. And it's exactly the same. I mean, supposing I wanted to, I mean, perhaps you wouldn't want to do this ultimately, but supposing you wanted to send a video clip to someone, well, read the data uh, chunk by chunk and send it out using a stream. No problem. All right. I mean, supposing I'm creating some kind of telephone service where you can talk to me from Cairo, and what happens is that I'm going to actually store that data in a file here on my hard disk. I'm not available to actually answer your phone call, but I can save it. And the technology is now easily understood. You send out your speech chunk by chunk, and I can save it chunk by chunk using a stream on my very high capacity memory that's on my laptop here. No, absolutely no problem. Okay. So again, any general questions? I mean, um, you'll get all the files, and you'll get uh, this you'll get a recording, probably in two parts again. Half of it's going to be the recording made by BBB, and the other half is going to be the recording made here at home. Okay, you sure, Ragad? Ragad, ask a question. Ask a question. Ahmed, any comments? All right. Okay, thank you. Okay, I'm going to take 5 minutes off. So I'll be back in 5 minutes. It's just to check on what was an earlier emergency taking place in the back garden. And can I tell you what the emergency was? Can I tell you what the emergency was? A sheep had jumped over the stone wall and were eating flowers. So I had to, in the time you didn't see me, I was actually showing sheep out of the garden which I'm staying. So, right. Okay. Okay, so I'll see you in 5 minutes from now. So it's 12:28, and I'll be back in. I should be back certainly before 25 to 1. Um, I think we're still London time. So okay, so I'll see you in a moment. Right, I'm back again. So, so what I promised is that we would have a look at TCP, the protocol. And so for the next half an hour or so, I'll tell you about and try and uh, give you a very clear top level view of what TCP is all about. So I'll load that presentation up. And So just bear with me for a few minutes whilst the file's converted and uploaded. So about a third of the way there. So I'm sorry, it's actually an 80 page document, and my interested in is just the first 50 slides of the document, and I'll skip over some of them sort of fairly briefly, but it does actually give you what I think is a very good account of TCP. So okay, I know that there are only two of you here at the moment, but can I ask a question? And as far as assessment's concerned, would you prefer an exam or would you prefer written take-home coursework? I mean, what would you like? Oh, still uploading. Goodness, it's very slow. Nearly there. So hopefully it's going to make an appearance on the screen in a moment. Nope, nothing yet. See what's happening. So I didn't quite hear you, Raghead. Okay, I can't. Oh, that's great. You know, if I can't see it. Oh, wonderful. No, there's no sign of it. And yet, It's well, I'm sorry, but I'm gonna have to do all that over again. This is not good. Wait a minute. I'm just going to try again. Well, I'm gonna try. First of all, I'm going to try an alternative. I'm going to visit the. Let's hope this succeeds. So I'm going to upload the Whirlwind document, and I'll try and look at this first. Thank you for being patient. Oh, it's still uploading. Um, Nothing at all. You can see it. Goodness. Well, maybe if I log in to another machine, I'll be able to see what I'm supposed to be teaching. So but please bear with me. Bear with me. Okay. Oh goodness. Thank you, Ragad. You gave me confidence that it was actually there and it was under a button. So I spend part of the day making a little bit more progress in understanding the Java programming language. And what I really want to do is just to review some of the ideas that we've looked at already. So it's you can think of this as partly as revision as to what some of the things that we've actually done. Um, so very good source of reading is the Java programming language, and it's a book by Gosling, and it's available online. I've given you a copy, but uh, I only want you to start reading that if you're feeling confident and you've got some time. Otherwise, have a look at, do read the one of the other two books I've given you, which will give you a clear overview of most of the important things we need to know. Right. So learning, as far as learning strategy is concerned, I'm going to leave it up to you to read up on Java's basic types. So I want you to find out how to declare a Boolean variable, or an integer variable, and various different sizes. And if you want to have a floating point variable, find out for yourselves, and you'd be able to look up the basic operators such as I++, which means um, actually represents the value of I plus 1. I'll leave it up to you to remind yourselves about loop constructs like while loops and for loops, and the syntax and semantics of a while loop, and so on, and find out about the string cast. So it's just all the basics. I'll leave it up to you. We've covered all these things in Python, so it shouldn't be any problem. What I want to do is to consider arrays in Java and get that under our belts, as we'll need this at some point in the early future. Right. And before I do that, I'm going to quickly review the contents of the objects.doc. And just to remind you again that you write a class by prefixing um, a name with and curly brackets with the word class. So I've got a class human, and that contains two items of data, or fields as they're called, or variables of specified types. So I've got height and weight, which are both real numbers, variables of real numbers. And here's an example of a method called setWeight, which doesn't actually return a value. So it's not like a function. It takes a single parameter x, and all it does with x is to assign the value x to this variable. So if you want to change the value of this variable, you can use setWeight. And the question is, how would you use setWeight? Well, I think I've given you no example here. No, I haven't. I'll actually tell you. You write the name of an object, human, dot, then the name of this method, setWeight, give it a value like 84, and that, when executed, will have the result of uh, assigning 84 or 84.0 to this real valued variable in human. And if we're thinking about let me just readjust what I'm thinking here. Supposing you've got a class human, and you create an object called human with a capital H, then if you want to change the value of height in human, the object human with a capital H, you write human dot setWeight 84, and that will result in the objects. In other words, human with a capital H's variable h height, you'll set that to 84. So remember, I'm just reminding you that a class contains data, and a method, or one or more methods that operate on the data, change the values of its variables. You can think of human as a package, which packages data and methods for operating on that data. And exactly the same thinking holds for an object made from the class human. The object made from the class human also packages data and contains methods for altering the data. Okay, and so I could have a class soldier, contains string variables, and so on. And to create an object from the soldier class, all I have to do is to write Sam, which is the name of a soldier, So type soldier, name of a type soldier, it's a new soldier, new instance, a new object formed from this class. And then we could write Sam dot soldier name is going to be assigned Christopher. And if you remember, the soldier name is a string variable in the soldier class. In the soldier class. Okay. Soldier name is the string variable in that class. If I create an object Sam from that class, I can alter the variable soldier name in the object Sam just by assigning it, by writing the name of the object, Sam dot the name of the variable soldier. Soldier name is a type string. Assign it the string Christopher. And so you just write the name of the object before the name of the method. And similarly, I could write Sam dot rank. What is the rank of the soldier that Sam represents? Well, it's a kernel, And also mentioned, I think I also mentioned static variables and static methods briefly, and have mentioned constructors too. But I'm going to spend some time talking a bit more about static and static methods and static variables a bit more. I think we should talk about them a bit more. But arrays. So arrays are simple variables that hold one value, are useful, but aren't sufficient for many applications. And a program that involves playing a game of cards would want a number of card objects it could manipulate as a whole. And to meet this need, you could use arrays. An array is, by definition, a collection of variables all of the same type. And the components of an array can be accessed by simple integer indexes, and have to be. So in a card game, a deck object might look like this. So what I'm doing here is to um, first of all set out what in fact is a constant integer, and it's going to be final. In other words, I won't be able to change it, and it's going to be static. In other words, the value of this deck size is going to be 52 no matter in which object deck size occurs. So if I've got some class in which I've defined deck size to be to have a static value, a static value. Oh dear, wait a minute. Let me just get rid of all that. Give it a static value. It's always going to be 52 in every single object. And I can declare an array as follows. So I'm going to declare an array called cards to be an array. So card square bracket means that cards is an array, and it's going to be a new object, a new array, in fact, with 52 indexable items. So I've marked this as being private. In other words, only the class in which this is defined can you actually access it. So what this line says is that cards is an array of type card, and I write that. And cards is the name of a new object uh, created from the array object with length 52. Whoops. Let me try and I'm finding. So explanation of all that is first we declare a constant called deck size. If you remember, that's 52 to define the number of cards in a deck. It's static and it's final, can't change it. And it's public so that anyone can actually find out how many cards there are in a deck. It's 52. And all you have to do is to write the name of maybe the class prefixed with and then dot deck size, and that'll return the value of cards in a deck. And next we declare a cards field for referring to all the cards. I mean, cards is going to enable us to refer to all 52 cards. This field is declared private, which means that only the methods in the current class can access this to prevent anyone from manipulating cards directly. The modifiers public and private, so these are called modifiers or access modifiers, public and private, because they control who can access a class or interface or field or method. So you can mark any of these items with private or public that you like. We declare the cards field as an array of type card by following the type name in the declaration with square brackets. Right? So that's how you do it. And you've got to remember that. So, if you want to declare something to be the name of an array, you have to specify the type followed by square bracket, square bracket. We initialize the cards to a new array with deck size 52 variables of type card. And each card element in the array is implicitly initialized to null. I mean, they don't receive any value. Before you use like cards 55 or 53, before you actually assign a value to that, then by default it's going to be given the null value. An array's length is fixed when it's created and can never ever change. Right, the printline method invocation shows how array components can be accessed. So in the little bit program I'm going to give you now, it encloses the index of the desired element with square brackets following the array name. So just consider this. So I've got public static final in deck size is 52. So that you're saying deck size is in effect a constant, doesn't change its value. Cards is an array of 52 cards. And what I'm doing here is to put a little routine called print. And for I starting with 0 all the way up to, but not including the card length, which is 52. And cards, I've declared a cards object, and it's an object, and it contains a method called length. So length, cards.length, actually returns the value 52. It's the length of the array. So after you've executed this, increment I by 1. So simply use system.out.println to print out the value of each of those 52 cards. The problem is, I mean, if you haven't actually assigned values to cards, then what I said earlier is that they've implicitly been assigned a value null. So you will actually have a problem because you can't print out a null value. So a little note on all that, and I'm mentioning the fact if you try and print out, say, the value of cards 56, that'll throw or generate an error, which you can catch or deal with it because there is an inbuilt bounds checker. Uh, so it'll actually return an exception of type array index out of bounds, and you can deal with that by writing an appropriate code, and we'll look at that sort of later on. So I'm just gonna skip the next few slides, and we get to what's very important is to really understand what a class is, and to be able to feel happy with using classes and creating instances from classes. So each Java program in effect is constructed around the idea of classes and instances of classes. And for the moment, you can think of a class as a general type or kind of thing which may or may not have instances or objects complying with those types. Right, so a class has instances or objects from which they've been generated. An object uh, is going to be uh, specified by creating uh, an item, if you like, from a particular class. Or you're going to create an instance from a particular class. And a class simply specifies the behavior of an object arising out of that specified by the class. All right, so a class completely specifies of any object from which you create from the class. And uh, anything that you can name or think about or point to is an object and will actually have a corresponding class. I mean, I can, looking out of my window now, I can see a mother sheep, and that object clearly is an instance of the class sheep, to make the point very simply, but it's worth understanding that. So given any class description or specification, any number of objects can be created at runtime. So at the moment a program's executed, that are in a precise sense instances of the class. I mean, an object you can think of as being a sort of in a sense, a doppelganger of the class. It contains the same variables and the same methods. And you can create another instance, and that's going to contain the same variables and the same methods. But there's every likelihood that you will actually, in the case of each uh, uh, object, each instance of a class, you're going to assign different values to the variables. In other words, objects have exactly the same properties and features of the class itself. And this ability or feature is useful in constructing programs that require many instances of similar objects. And we've just seen an example. We're thinking about a game that involves playing with cards. What do we need to do? We need to create uh, an object called card and a pack of cards, in other words, and there are 52 of them. All right, like if I wanted to, I could create several different packs of cards. I mean, maybe I don't know, I'm perhaps simulating a game of bridge, or I'm doing something. I'm playing a game simultaneously with two packs of cards. Well, I can very easily create two packs of cards uh, from that array. I mean, I might have a database of bank customers. Oh, it's called a database, and maybe it's got 1,000 instances of customer. There's Chris Kinberg, and there's Ikram, and 999 eight other customers, each having similar features, but all quite individual. Right? Or a type of locomotive or traction engine, each of which has a particular wheel configuration, engine, traction power, brake horsepower, and so on. I can easily model 100 trains by using a single class. And the single parent class is actually going to have all of the data variables I need to represent a specific locomotive. Or I might want to model a collection of vehicles, each of which has an entirely different braking system. All right. That sort of reminds me of what we were talking about first thing today. So you can think of a glass as a blueprint or a stencil or a master template, or even in philosophical terms as a platonic form, if you like, together with instructions or a specification of how to build each particular objects that you create. And you can actually, when you create an object, you can individualize it using constructors, and I'll say a little more about that later on. So a class is nothing more and nothing less than a blueprint for the creation of objects. Need to know how to define or declare a class, and how operationally we can create instances from the specific class. Nothing difficult about that. And all that you should bear in mind is that from a logical point of view, class contains two different kinds of things. It's very, very simple. Right? Members, which are variables of a particular type, like integer variables or string variables, and they're often called fields. Fields. And secondly, methods. I mean, you could actually include other things within a particular class, because you can actually contain other classes. And I think within a class you can actually define an interface, but that's a whole new story. So let me see if I can turn the slide. So all that we should bear in mind is that fields represent the data belonging to either the classes or instances of the class. And fields are represented by variables, such as ints or strings, at the basic level, to very complex data structures indeed. If you want to include variables of complex data structures, representing complex data structures. And methods are collections of program statements that more often than not operate on just those fields. Right? So, for example, you might have methods that alter the value of an object's fields, and manipulation of an object's fields is in fact a manipulation of the object's state. So I'm now thinking of a class and an object as representing a package of data and operations on that data. And what I'm now thinking in terms of is seeing objects as having a particular state. It's the sum total of the values of all the variables. And I can change the state of an object by changing the value of one or more variable values. And in software engineering, a state diagram is associated with complex objects, such as a controller. For example, I could model a lift class. So I want to model a lift, and I'm modeling it by using a class lift. And inside the lift, I can have lots of variables, like one variable might be which floor is the lift currently at? And a second variable might be uh, jobs, and the jobs represents, uh, I mean, it could be a Boolean, just yes or no. Is there work to be done? Yes or no. Or a third variable could be um, door, and that represents whether or not the lift door is open or closed. Again, it could be a Boolean. And such an object that results from this class, probably needs a state diagram, a state diagram to explain what the lift is capable of doing. Because the operation of lift is actually quite complicated. And it might be very useful to represent its actions, its possible actions, by means of a state diagram. For example, responding to the press of a wall button inside or outside the lift uh, will will trigger the potential of the lift moving in a particular direction, or uh, or maybe after the lift has stopped at a particular floor, uh, in response to that floor's button being pressed to access the lift, will respond appropriately to the button pushed. Or if I press a button, the lift is actually going to move upwards towards the calling level of the building or the person on a particular floor that's pushed the button. And what I mean, we've seen state diagrams. We've looked at diagrams of this form, because I remember when in term one, we spoke about state diagrams of threads. A single thread could be in any finite number of different states. For example, it could be running, it could be waiting, it could be blocked, and so on. And I gave you a diagram that looks a bit like this. And the operation of the lift might be spelt out in terms of all its behavior. Its behavior can be described in terms of a diagram like this. So if somebody pushes a button, then such and so happens, and the lift moves upwards, and etc., etc., etc. When it arrives at the particular floor that's been requested, it'll open its doors, and maybe it'll actually turn off the illuminated lift button if somebody in the lift actually pressed the button. So anyway, Java is a good example of a general purpose, object-oriented programming language, and provides all the tools needed to solve programming problems using the broad technique of using classes and objects. You don't need anything else. Everything can be represented by means of classes and objects. And every object, if you're using it in the Java programming language, has a corresponding class that defines its behavior and its data. So I'm thinking at random, I'm thinking about the class human being, and very complex biological machine, but I could actually model it in part by maybe 1,000 different variables and maybe 600 methods. Like one method might be run, and I could run faster, or I can turn my head, or I can look upwards, or I can listen to what's being uh, said by Raghead, and so on and so on and so on. So at random, I think you'd be able to um, agree with me that it looks highly likely that you can do an awful lot of good modeling using objects and classes. Just remembering that a class is, the general template for the manufacture of lots of different objects, and you can actually spend time uh, giving the details of a particular class that you need in Java in order to solve problems, um, and so on. I mean, supposing you have a database of soldiers, I mean, what are the likely operations that you need to to execute on your database class? And maybe it's to to perform a search on all those soldiers who are actually under 65, or search for all soldiers who are capable of running a mile in 4.5 minutes, or are identifying all the soldiers in the database who have got a limb missing or have been involved in active service, and so on. I mean, maybe that's the sort of thing that you'd want, the context in which you'd want to use classes and objects. Okay, every class is a subclass of the super class object. Everything starts with object. All right, it's an extremely abstract, rarefied entity, and it's the mother of all subclasses, uh, um, which gives you common or garden classes, and inherits several important methods from object. So I'll tell you about those one day. And what we mean by class A subclassing a class B is that it extends class B by not only containing everything in B's, from B's variables and methods, and everything in addition that A itself contains. Alright, so if A is a subclass of B, A contains everything that B contains, plus a lot more that you, the designer, have put into A. Right? And B is said to be a superclass, and A can contain more fields and methods than B does. Right? A contains typically more fields, more variables, additional methods than contained in B. And we can also say that where A extends B, or A is a subclass of B, A inherits all the methods and variables, etc. from B. Okay, so think about that. Inheriting methods and variables. In virtue of the fact that A contains everything in B, it inherits all those. And if a class B specifies um, some data, then if A is a subclass of B, then A is going to inherit all that data for free. And the only exception to that is that if B contains variables marked as being private, then B can't use those variables directly, but it'll probably have to use one of uh, B's methods that have been marked as public to access the variable that's in B that's been marked as private. So you can think of a class as wrapping up of data and packaging up of data, and it provides just the operations that process the data or otherwise determine the behavior of the class. And in the sense that methods change the behavior of the object. Right? So fields and methods have different levels of what's called visibility. I mean, if class B has a method M, I, who am outside, I'm not inside the class B, won't be able to use that method if it's been marked as private. I could use the same method if it had been marked as public. So we're back to the question of access and access modifiers. So I'm just trying to change my slide. What a silly system this can be. Right? Okay. For example, one method might not be visible at all to the outside world, but might be invoked by a method contained in the class that is visible and executable. And by visible I simply mean accessible or usable. And levels of visibility are determined by the modifiers private, public. Well, I put etc. here, but what else? But what else? What else is there? Oh, no, back to that. Back to that. Um, I don't know. Let me see if that. No, I've got a. This system here doesn't allow me to draw at the moment, but never mind. Right. So other methods may be required to be accessible by all the child classes, but not the outside world. So I might have a class B that has a subclass uh, C, and C has a subclass D, and D has a subclass E. And E contains, let's say, 10 methods. Maybe I don't want those 10 methods to be accessible to the outside world apart from one. So I'm going to mark all those 9 methods that I want to remain private to be private. Okay, so it's important to realize that some methods might only be visible within the class itself, and the same holds for data variables too. So I'm just going to spend what few remaining minutes we have to talk about object creation. So if you're given a class definition, you may wish to use or what's called reify instances of the class. Reification means to make into an object, to make real, to create, to reify. It's quite a nice word. Instances of the class in the program you're writing. And it's easy to create an instance. You simply say something like Xbox 360. Well, I'm going to create an object of that class and I'm going to call it red. How do I do that? Well, I'm going to assign it the value of the result of creating a new Xbox 360. Notice these two brackets, which represent this class's constructor, which I'm not going to actually parameterize, put any parameters here. So if Xbox 269 is the name of the class, what am I talking about? What's this bit? Not, I mean, what? Ah, dear. Right. I'm going to get rid of all this nonsense. Um, uh, so let me try. Okay, I've got a pen at long last. What on earth am I talking about here? It should be if Xbox 360 is the name of the class that you've actually bothered defining. So object creation, and we've seen this already in the context of creating streams from stream classes. All right. Name of the stream, results, uh, the to create a, a stream whose name is red, then you use the keyword new and the stream name. Okay, so hopefully you've got some kind of handle on that. And I mean, sometimes you will need a unique valued data field to be possessed by each object you create. For example, if you have a class called Xbox 470, you might want to define it in the following way. So here's the class name, Xbox 470. And this time it's got a variable called designer, and it's of type string. And I've marked it as being static. And I've got a couple of other variables, serial number and the build number of an Xbox. And the purpose of making this variable static is that I don't want anyone to change it. No matter how many objects I create from this class, I want the fact that Erg Luxon was the designer of the Xbox family. And I'm going to insist that that is static. I can't change it to Chris Kinberg. That would be, it's not what I want. That's not part of the object's behavior I want. So the three variables, designer, serial number, and build number, define the class or object state. And initially, part of the Xbox 470 state is undefined. Each object should have the value of the data field build number set to the actual individual device's build version. And this will be in common with sets of particular Xbox 470s. For example, those built in Redmond rather than in Dallas. But serial number should be always unique to the latest or whichever object you create. Each object should have a unique serial number. And on the other hand, designer might be a variable holding a variable that's common to all the Xbox sold in the UK. And the value would be Berg Eklund. So Java allows classes to have variables of the latter sort, and they're static. And another way of describing those variables, they're called class variables. Class variables. And methods can be declared as being static. And supposing your class is called Xbox 99, or perhaps Belkin Wireless Router version 55, you might want to keep the next serial number to be assigned to the next Xbox or to the next Belkin router to be modeled in a static variable, so that when the next Xbox is created, it's given the next unique serial number. And the point about static and non-static variables is that a normal non-static variable declared by, say, serial number is that the value stored is unique to the particular object, but not to every object created. But if we had instead serial number being marked as static, then the value of this variable would be the same in all the objects that are created, which is not what we want. It's a bit like a variable whose value is global to all objects, to all instances of the class. So we need to find out a way of ensuring that serial number is unique. And it's got a few minutes left, and I took I think 10 minutes time out from the session earlier. So little aside, as it were, little momentary diversion. Occasionally, an object needs to know its own reference name. Well, why? Well, I know that I'm Chris Kinberg, and I can actually say things like my eyes meaning Chris Kinberg's eyes rather than eyes belonging to somebody else. And this in Java, so that's a Java keyword, is a reference to the name of the current object. And if you like, it is the name. You can think of it as being the name of the current object. So supposing I've got a class blah blah blah, which looks like this. So this is my class, and I think this is probably, I've got an integer. I've got an integer string. That's surely wrong. So I'm going to correct that on the fly if I can, and I'm just going to put a line through it. So this is a mistake. So it should be just string designer. And I'm actually initially assigning it the empty string. So here and here I've got inverted commas, nothing in between. So it's string designer, well, we don't know. I've left it undefined. And I've got a method called to, and what it does is to take a string as an argument or as a parameter, and then when I execute to, it's going to set the name of this object, which is blah blah, designer, or whatever. No, it's going to be the name of an object. It's going to set the value of the variable designer, this variable here, to be the one that you plugged in, if you see what I mean. So this use of this allows us to ensure that the first occurrence of designer in the definition of the method refers to the object's field designer and not the parameter name designer in the method too. And supposing I've got two methods, 1 and 2, in the class Xbox. So here um, I've got method 1, which I haven't actually said what it does, but it's public, has a void value. I've got method 2, which is a build number, and I've got this dot build number is going to be assigned value of the value of this string build number here. So I'm using this to refer to the name of any object created from Xbox, and I'm referring to this particular variable here. I'm not, when I say this dot variable is assigned build number, um, sorry, yeah, I'm actually saying that whatever I specify here, like 1567, is going to be assigned as a string to build number here. So I can set the build number simply by writing Xbox. No, I can't. Export. Yeah, I can. Export. Export. Xbox dot 255. Well, I'm not sure about that because I'm going to have to think a little bit about that. I can only use the class name to let me see. I'm using Xbox 2, so I'm trying to refer to this method here. But really, to make sense by prefixing the method by the name of the class, I should write, let me do a line here and here. Let me just do this, here and here. I should have marked these as being, let me see if I can write, this is so difficult. I should have prefixed these as being a static method and a static variable. So I should have prefixed these two lines by the word static, so that in any programming context I could actually say Xbox dot 255. And that's actually going to refer, the fact that I can use the class name means that I can actually refer to method 2, and I'm going to supply a build number. That should have been an integer. So never mind, I'll try and repair this and when I put it up. But if I'd created an object called my Xbox from Xbox, I could have written my Xbox dot 2. My Xbox would be the name of the object dot the name of the method I want to set. That would have been fine. But as things stand, I shouldn't use the name of the class unless I mark string as being static and this method as being static. But oh well. Am I running out? I have run out of time. Okay. How to create an object? Just a couple more minutes, please. Ladies and gentlemen, how to create an object. An object, say CK's Xbox, is created by writing CK's Xbox is of type Xbox, and it results from creating um, an instance, an object from the class Xbox. And in that case, it would have been fine for me to write CK's Xbox.1 and CK's Xbox.2 with this string serial number. In other words, I'm making this the serial number a string. I mean, I could have made it an integer or a floating point in an integer or something like that. So the latter method will set the variable build number to the value 232, etc. But okay, well, I'm probably going to finish it. I'm not happy that I'm finishing it, but I'm going to finish it. One way of understanding this is reading the first line as send a message to CK's Xbox to tell it to execute method 1, and then send another message to method 2. Send another message to CK's Xbox to execute method 2. And sending a message to an object is the terminology related to executing a method in object-oriented terms. Right, you can send a message to the object, send a message M to an object. So, and okay, I'm really going to finish now because it's 1:36. So I can actually obtain the value of the serial number simply by writing the name of the object dot serial number. Okay. To access the value of a static variable designer, we've got to write the name of the class. What? That's wrong as well. So I don't actually, in what I've shown you, I haven't actually got a static string. Let's see. Oh, I have actually. Yeah. Okay. I've got a static variable called designer, which is of type string. If I wanted to find out what had been assigned to that, all I need to do is to write the name of the class of Xbox dot, and that should be designer. So I'm sorry, let me cross that out. So I might not bother. Oh, it's so difficult to do joined up writing here. I'm going to try. So hopefully you can read that. Designer. Ah, that's a funny E, and that's an R. So put a dot there, a little dot here. So it should be Xbox dot designer. Right, and that'll return the designer's name. So tiny bit more, which I think it's important. So we'll spend about 10 minutes next topic sending you that information. Okay, Ragad and Ahmed, are you still both alive? I finished. It's been a hard session. Ragad, are you still there? Ragad. Ahmed. Oh, hello, Ahmed. You're very patient. Okay, okay. So, Ragad, do get in touch with me about pending matters if you want to. You know, things like coursework and everything. Do make any comments you want to. Um, and I've got a bit of news for you anyway, so do get in touch with me. Ahmed, keep me informed. Uh, Try and work through some of the material that you've been exposed to this week, and I assure you that if you do, it'll pay dividends in the future. So, but honestly, if there are any issues that you want to discuss, either of you, let me know. Okay. So have a good week and God bless you both. All right. Take care. Bye bye. Bye bye.